Our agenda for today, we're going to start by talking about goals of digital transformation in manufacturing. We're going to move on to classical architectures that have been used over the past 25 years and issues with those architectures. We'll get into the unified namespace architecture. We'll review a project that we did with one of our customers that we implemented this architecture. And then we can get into references for other, articles, websites, YouTube channels that you can look at and potential next steps, right? Okay. So when we talk about digital transformation at NeoMatrix, we have classically stated that it involves having all stakeholders in your business know the state of the business in real time. And all stakeholders, meaning people, but also your assets, so your equipment on the plant floor and your business system. So all your enterprise business systems, whether that be your ERP platforms, your MES platforms, quality, SCADA, right? They all have access to the information if they need it. I think a lot of the folks on the call really come from automation and dealing with manufacturing on the plant floor. If you could just think of if you had, a PLC and an HMI that had access to all the information from a work order out of your ERP system in real time, how valuable that could be, right? And then the holy grail is if you could take all of this information that you've gathered and pump it up into the cloud and do some artificial intelligence or machine learning on that data, that's really where you can start to gain some benefits, right? And find patterns and predict outcomes and recommend some adjustments, right? And I'm not a data scientist, but there's a quote I found here that and I hear this a lot, that when you get into AI and machine learning, these data scientists spend 50 to 80% of their time cleaning and preparing the data in order to get your results, right? So I think one of the goals of the unified namespace architecture would be to have that data ready to go when you get to that stage. And it also will provide that value, number one, in digital transformation, that you'll have access to all that information in real time, right? So even if you're not looking to get into the AI and machine learning aspect, you still could provide some value with an architecture like this. Okay, so if we go classically in manufacturing, and sometimes this is referred to Industry 3.0. People refer to it as the Purdue model as well. But classically, the stack in automation went from sensor to PLC to HMI, SCADA, MES, ERP, right? And those platforms are integrated linearly. Right? So if you want to get information out of a PLC into your ERP platform, classically, that's been integrated through SCADA, then MES, and ERP. So you need to have 3 to 4 touch points to move that data up and down the stack, right? With Industry 4.0, right, you can now, with the way software systems are written, you can theoretically connect the PLC directly to your ERP platform, right? So it's technically possible to do this today. But if we build this out and you think you want every single system to have access to one another, you're going to have this web of discrete integrations that you're going to have to program and maintain, right? And we like to refer to the classical handshake problem. If you have 5 people in a room and everybody needs to shake one another's hands, what's the formula for that? So it's, n times n minus 1 over 2, n being the number of nodes, right? So in this example here, we have 5 nodes in the system. It would take 10 discrete integrations in order for that to happen. And while this isn't exponential, it is quadratic. So if we just add one more node to this, you're now looking at 15 discrete integrations. And one thing to be really mindful of here is, let's say someday you wanted to replace your SCADA platform. You're not just replacing the functionality in that SCADA platform, you would have to also replace any of those discrete integrations that you've done to any other business systems, which could also involve bringing in people that own that domain as well, right? So it could be a pretty complex task to replace one of these systems. Moving forward with the unified namespace architecture, instead of doing discrete integrations, we would have the unified namespace kind of be the central repository of all information. And all of these different business systems would integrate directly to the unified namespace, not to one another. Right? And so here with the handshake problem, your result is you're doing 5 discrete integrations. And if you were to undergo something like a SCADA replacement, you now only have to replace the direct integration to the unified namespace, and any of the functionality that was occurring with those integrations from the ERP, MES, HMI, and PLC platforms would automatically pick up because you're going to be publishing to the same place in unified namespace as you were before. Okay. So what is a unified namespace? And I think a lot of you may have heard this term before. And it's open for debate. There's a lot of debate about this out there in different communities. But at its simplest, it's an architecture in which businesses and industrial applications can exchange and structure data in real time. So we think there's 2 components to this. One is there's a central repository that's based on scalable, open, and secure technology, right? And then that central repository has access or stores that real-time data, but it's got to be structured in such a way that people can find it. So there's a semantic hierarchy, which makes it easy to find data, and it's based on industry standards. Right. And when we talk about unified namespace, we don't talk about any vendors, right? It's vendor agnostic, right? So you should theoretically be able to use anyone's platforms out there for anyone. You don't have to go with an entire stack from one vendor in order for this to work. And in order for that to happen, right, or the other recommendations we make here is that it's got to be an open architecture, meaning the software or hardware that you're using has documented and open methodologies to get data in and out of the platform. From a communication perspective, it should be report by exception or pub sub. So classically in automation, things like OPC-UA, and there could be a debate today that OPC-UA supports pub sub, but classically that's more of a polling mechanism. So if you had, you were polling a PLC for a temperature per se, you would have to be polling that once per second continuously in order to get updates. Whereas report by exception or pub sub, the device publishes information as it changes. So if you think of something like a valve state or something doesn't change very often, a valve is open, a valve is closed. If that only changes state once a day, that's one transaction per day versus the 86,400 seconds in a day. So if you're polling once a second, you're going to have a lot more traffic on the network, right? It's edge driven, and what we mean here is that the intelligence or the data is modeled and pushed from the edge, right? So that gives a bunch of advantages. One is you're modeling it, and the subject matter expert of that data has the opportunity to model it, and they push it to the unified namespace. And as it's consumed later on down the road, you no longer have to do any data engineering in order to put that in the proper format or context to understand it, right? It's lightweight. So if you think of at scale at a company that could have dozens to hundreds of plants across the world, you may think of in a single plant or area of a manufacturing environment, you don't need much from a networking requirement. But if you think of billions of data points in real time trying to come together at enterprise scale, you need to make sure this is lightweight. And then lastly, we feel security is important these days. So having things like authentication, encryption, and access control lists to who can access what data is important, right? Okay, so as far as the central repository goes, we feel that today an MQTT broker is the most sophisticated methodology to get this done. And while it's 20 years old, 20 plus years old as a technology, there's some confusion out there as how this works, right? So the goal here is to try to explain MQTT. So an MQTT broker is an intermediary entity that enables MQTT clients to communicate, right? And there's two types of clients. There's clients that would publish to the broker and clients that would subscribe to the broker. Okay? And you can have clients that do both. Right? But what happens in this scenario is the MQTT publishing client would have data and it publishes its data to the broker. And then you have subscription clients that subscribe to information from the broker. Right? And that subscription, you can subscribe to only certain parts of the namespace, right? So let's say you have multiple publishing clients that are publishing data. Some could be from a PLC, some could be from the MES platform. You could subscribe to specific areas, right? So the client doesn't have to subscribe to everything in the broker. It can say, I only want a subset of this data, right? So the broker's job is to receive the data from the publishing client and then disseminate that data to anybody that's subscribing to that. And I jumped ahead here one slide or one animation really quickly that to show three clients that are subscribing to the data. This could scale exponentially, right? You could have hundreds to thousands of clients. But from that MQTT client that's publishing the data, it doesn't really care who's subscribing to the data on the other side. And that's the power, right? Is I'm going to publish that data to the broker once, and then as many people as you want can subscribe to that information because the communication is never directly between two different clients. Okay. So the second part of a unified namespace is a semantic hierarchy. And it's suggested to be based on industry standards, and ISA 95 has been around for quite a while and it's been adopted by industry. So we feel it's a good place to start. And the part 2 of the ISA 95 definition talks about this hierarchy of a manufacturing enterprise where you would start at an enterprise level, then you go to site, which would be a physical location. So let's say with Neomatrix, we have a site in New Hampshire and we have a site in Massachusetts, right? And then you can have multiple areas within a plant. Those are just logical groupings of equipment or process areas. So you could have a production area and a packaging area, right? And then underneath that area, that's where you get to the actual equipment that does the production of goods, right? And in the ISA 95 hierarchy, it lets you break that down into cells or cell groups underneath the line. But for all intents and purposes, the line is where the production starts, right? So that's pretty standard in MES and even in ERP and other systems where you're modeling your plant, right? What we would add from a unified namespace is what we call functional namespaces, right? So within that line level, what we would suggest doing is adding in a functional namespace, which is very similar to just a folder, like when you're organizing files on your hard drive. And we would recommend that any of the clients that are publishing the data, they have a unique space in this topical namespace structure to publish their data, right? So let's start with just the PLC, right? So let's say the PLC is going to post line state, speed, temperature, right? Whatever other variables you feel would be necessary, right? So there would be a folder under enterprise site area line 1 that has PLC data. Then we can add, let's say we're going to add an MES application, right? So here, this is where the power of the unified namespace starts to act, is the MES platform can subscribe to information from the PLC data and then go through its algorithm and calculate things like OEE and availability and performance, and then publish that information back to the broker that could then be consumed by other applications, right? And similarly with ERP, right? There's a lot of information in your ERP platform, such as your schedule, right? What am I supposed to make today? Then with a work order, what's my part number quantity, start date, due date, right? The ERP platform could be responsible for publishing that information. And we're not going to get into it so much in this presentation because we only have a half hour. But some of you may be thinking, well, my ERP platform doesn't speak MQTT natively, so how is it going to get that information in there? And that would typically be the job of something like a data ops solution that would be able to interface to something like a REST API and convert it to MQTT, or potentially you could have an IoT platform out there that could handle those transactions for you. So I'm not trying to fool anybody here, right? That big perfect circle with all the different business systems don't automatically be able to publish to MQTT. Sometimes you need an intermediary. But in general, this is what the result would look like. So then for a project snapshot, we did a project with a medical device contract manufacturer, and they had islands of automation. They really had no network on the plant floor. And in this particular packaging area, they had 6 lines, and I only drew 4 here just for real estate on the slide. But they had 6 identical packaging lines that were all made by the same OEM. And they all had a compact logics processor on them from Allen Bradley. And each one of these systems were identical in the sense that all of the networked equipment had the same IP address from line to line to line, right? So it's a classical integration problem. When you get equipment into a plant from an OEM, they're all going to assign an IP address, let's say, of the PLC to 192.168.0.1, right? And every PLC has an IP address. So that's really difficult to integrate into an enterprise network. A lot of times companies will force you to change the IP structure of that equipment, but that could be pretty costly and potentially void warranties, right? So what we decided to do is we decided to put in these Maple System gateways. They're fairly inexpensive. They're about $500. And what they do is they can speak Ethernet IP to the PLC. And you may not be able to see here, but there's 2 Ethernet ports on this device, right? And so what that allows is one Ethernet port will speak to the PLC, and then the other Ethernet port can go on the business VLAN. And then what we can do is that device supports talking to up to 300 different PLCs, but it also supports publishing to an MQTT broker, right? So we took the data from all of these processors and published it to a unique space in the MQTT broker, right? And essentially for a cost of $500 per line, we didn't have to reverse engineer or change anything or invalidate any warranties that are out there. And we have all our data in a broker now, right? So one of their goals was to, I'm sorry. So now in our namespace, you can see after we're publishing, we have XYZ Corporation that's in Massachusetts. They have a packaging area, and then line 1 has a PLC topic namespace that has things like state, in-feed counter, and out-feed counter. Okay. So then we added an ignition platform, and one of the goals they had was just to visualize and historize data, right? So that ignition platform there handled that functionality. But we also added a Cepasoft module to do OEE, right? And so the Cepasoft module was able to ingest the PLC information, calculate APQ and OEE, and then publish it back to another namespace under line 1 that had all of this data in real time. And then lastly, they wanted to integrate ERP information, right? So they had an ERP platform called IQMS, and I mentioned earlier, right? Like, well, not all of these software systems speak MQTT natively. So how do we get that data in, right? So what this company had been doing for years, and some of you may be familiar with this, is they just did a data dump for every transaction that occurs in IQMS, or whether it be on a time or scheduled basis or on an event base, but they essentially dump the data into a CSV file, right? So what we ended up doing is we used Node-RED, which is an open source data ops tool that ingested the data from that CSV file and then published it to another namespace, topical namespace within line one called ERP. And there we were able to, in real time, get information at IQMS that had things like work order, part number, and quantity that now can be ingested throughout the enterprise, right? I also forgot to mention here the MQTT broker we used in this scenario ended up being Mosquito. Mosquito is an open source broker, so there was no cost to it. There's definitely some other brokers out there from other folks that we would recommend in a larger, more mission critical project. This was kind of a proof of concept, so we ended up going with open source to save some money. Same thing here with Node-RED. There's some other data ops tools out there, or even Ignition could have potentially handled this, but we felt like that was a better place for that functionality to reside. So that's the gist of that pilot project we did for this med device contract manufacturer. So then just to sum things up for references and more information, there's a community out there, there's a company called 4.0 Solutions that a lot of this information that I've learned over the past 2.5, 3 years, I've gotten from them. They have a lot of great information on their YouTube channel, blog. I meant to say podcast there, but the YouTube channel and podcast are basically the same thing. There's a Discord server out there. That's great. There's over 5,000 members in there that just exchange ideas and information at all times. That's free. And then there's a IIoT University, which is a subscription basis, but they have hundreds to thousands of hours of great information up there to learn about Unified Namespace and just digital transformation in general. HiveMQ is a vendor of an MQTT broker, and their blogs are great. So if you follow them on LinkedIn or just subscribe to some of their blogs, that's a great source of information. And then in general, NeoMatrix, we have a blog, a newsletter, and some social posts that if you follow, there'll be some good information there as well, right? So as far as next steps, we're going to send all you folks that have attended an email that will have links to all those references I just mentioned. So where to go find that information, where those blog posts are. If you'd like, and this will be in the email as well, we have another interactive demo we've done with folks where we actually build out a unified namespace cooperatively in about an hour. And that would be you folks on your end, you would be using, we typically use a product like Ignition because it's free to use and trial. And then we would host a broker on our end, and we all would build out a local namespace, publish it to the broker, and then be able to consume everybody else's topical namespaces that they're publishing. And I think that really shows the power of how this works and how quick you can get something done and start exchanging information from a number of different people. And then lastly, we'd be happy to schedule a complimentary consultation with you, free of charge. Spend an hour or two with you just going over your scenario and recommending methodologies or tricks that you could use to help take the next steps. Right. So that's the end of the presentation. JT, Chris, I don't know, did we get any questions? I don't think I see any in here.
I think we got one from Anthony. He says, could you use the Maple Systems MQTT gateways to write information back to the PLC? Example, load a recipe into the PLC?
Yeah, absolutely. I didn't show that in that slide because one of the things they wanted to do in this example was, from a security perspective, they wanted to make the flow of information go in one direction. But this communication between this gateway to the PLC can certainly be bidirectional. And so you could actually have this Maple Systems gateway consuming some specific information. So let's say you wanted to look at the ERP information, right? You could have that gateway subscribe to that namespace and push it back to the PLC. So it's a great way to enable bidirectional communication to a number of different PLCs out there that don't support MQTT. There are some, most of the newer PLCs today are coming out with either a module or MQTT embedded in it, in which case you wouldn't need that gateway, but certainly you could do that with recipe information or any other information that's coming from anywhere else in that namespace. Good question. Cool. Is that it?
Couple others just came in. Is there any difference with what you are doing with the maples and natting?
Yeah, that's a good question. I'm not a network expert. I think it is a difference though, because technically there's two IP addresses there, right? So one of the IP addresses on the Maple Systems gateway would have an IP address that's on the VLAN of the broker, right? Whatever this we decide to call this VLAN, whether you call it a manufacturing VLAN, and then another port on the switch would have an IP address local to the automation network, to the PLC network. So it's a little different than that, where I think there you would have a single presence that just forwards the information with an IP address. So I think it's technically different, but again, I'm no network engineer expert. So that's about the level of my knowledge there. And if that's not satisfactory, I can follow up. And I'm looking here, there's another one. Would you consider the UNS to be different between an enterprise and factory floor? Yes, and I actually had another slide that I didn't put in here. So one of the great things with MQTT, and I mentioned security briefly, but in a lot of companies today, they're segregating different levels of your organization and restricting what information can be passed back and forth, right? So one of the great things about MQTT is that this broker doesn't have to be a single broker in your enterprise. I don't know where that slide, I wish I had it. But essentially what you could do is you could have, within one site, you could have a broker for every area. And those area brokers could publish their namespaces back to what we would have a site broker, right? And then every site could take the data from their site broker and publish it to a centralized enterprise broker. And that's fairly simple to achieve. And there's some other advantages there as well. A lot of them have to do with security, but just in simplicity, what's great about that is when you're starting off, right? If you go with this architecture, right, you now have the ability, your information is already in this unified namespace and formatted so that it's ready to go when you do get a site or an enterprise broker and publish that up. I see one more coming in. Welcome. All right, so I think that concludes the webinar for the day. Again, we'll send out an email and appreciate you all attending. Right. Thanks, everybody.